This conference will now be recorded.
Welcome everyone to another OCP TAP session. This is actually the 67th of the series. So today I have Gustavo Lopez presenting to us about timing resilience and security at the core of GNSS technology. Before I introduce the speaker, just wanted to let everyone know that we will have the kickoff meeting for IEEE 3335, which is basically about the standardization architecture for a time card coming soon. And if you're interested, again, if you search online IEEE 3335, you can get like all the info and then where you have to register and so on. And I promised my friend Lasse, he's pretty excited. We're gonna have a different type of call on April 12th. Should have been April 1st, right, Lasse? So April 12th, which is gonna be basically a round table. And Lasse, quickly, what is just like a sneak peek?
Gonna be great. That night we're announcing that we've discovered a way to travel faster than light. Okay, that's why everyone needs to attend. No, it's not true. On that night, okay, we have some very interesting speakers. So it's a new format where every speaker has just 15 minutes. The topic is going to be PTM, okay, which is this amazing new way that inside a standard PC server, you can exchange time between line cards or network cards and the CPU. And we have Intel, we have NVIDIA, we have AMI, who's all going to talk, and it's going to be great. I encourage you to turn up on that night. It's April 12th, PTM night.
Wonderful, wonderful. Okay, so let's start with introducing Gustavo. So Gustavo is Market Access Manager at Septentrio, a leading company in bridging high-end GNSS technology where accuracy, reliability, and GNSS security matters. Gustavo, since joined the company, has held different technical R&D and product management roles and has been involved in some of the most innovative and reliable solution used in machine automation, autonomous systems, robotics, UAV, and other demanding and critical applications. Gustavo's role is a visionary and with expertise on different market especially when linked to navigation, positioning systems, and resilience of GNSS. He's active in multiple groups and network adopting for these technologies. I hope TAP will be also added to that list. So Mr. Lopez holds a Bachelor of Computer Science from Monterrey Technology Institute, Mexico, and a Master in Business Administration with Information Technology connection from United Business Institute in Brussels. So with no further ado, Gustavo, the floor is yours.
Thank you very much for the nice introduction. So yes, indeed, the topic will be today around GNSS technology, and indeed the topic is really to understand what's happening in the core of GNSS systems, especially when we're talking about resilience or the security. I know resilience in timing can mean even a more global parts also in the general systems. But when we are talking about GNSS aspects, we are referring to some very specific elements, especially in the jamming and spoofing type of effects. So I will definitely cover those here. I'm sure that many of you have heard about those topics, but I want to give a bit more in-depth information about what's happening on the GNSS technology itself. Well, I like this quote actually that you will find online, and it's from Robert Mueller, which is the FBI director, and he says there are only two types of companies: those who have been hacked and those who will be hacked. And I believe the same applies when we are talking about GPS or GNSS systems. those systems will be hacked, and many have already been hacked. And it's a lot of the education know-how that we need to make sure that that is spread around this part. So very interesting to see what's happening in the GNSS world nowadays. And for me, one of the things I like to make an analogy of when we're talking about GNSS security is to go to the basics of what we have seen in computers. I mean, I think in computers, through the history, we have seen a lot of computer viruses popping up already from the past. All that got started, by the way, by universities, where they started to make the first viruses in 1971. And then after that, of course, there was a mass increase of attacks, basically, in terms of viruses. And if you think about it, nowadays, we believe that the technology is quite well suited in order to protect our computers, as long as we have, of course, the right updates and system behind. But we know that there is already much more awareness in terms of the security that happens in computers. So that's definitely interesting to see. But when we take a look at GPS and GNSS side, I think there is still a bit of learning side to do in the risk actually that this security could happen for different type of systems itself. So very interesting to see that. Nobody would like to see, as an example, planes cancelled, suddenly delayed in an airport, right? Because of a GPS jamming or spoofing attack or something similar. And actually, this has happened. So there has been already some use cases in where you will see this type of attacks. As an example, in the airport in Dallas, they had to close after there was some interference detected actually by the airport authorities. So actually they had to ground the airplanes behind that as well. So we're not talking about fiction. We're really talking about incidents that are already happening nowadays in terms of the attacks there. The same situation could happen, as an example, with traffic lights. Let's suppose the traffic lights are not suddenly working at some point due to a GPS failure. Could that really happen? Well, actually, you will realize that yes, this can happen. This is an example that happened actually in New York. At some point, there was also GPS malfunction that basically knocked down the wireless network of the city there, and they actually had a problem with controlling the remote traffic lights behind it, and even the license plate readers, as you can see here in the picture, also were of course affected as well. So it took about 10 days to get the network running again. So again, the type of effects that we get to see are not anymore fiction, are really happening more and more. Why? Because GPS is used also more and more in different type of systems. And you can see here the type of applications where GPS is coming today. It goes everywhere from your banking transaction at the ATM all the way to the power grids that are using basically this timing. I think you guys know quite well the risk in critical infrastructure behind it, but it goes also to many other applications, and it's being adopted more and more in systems. Call it, as an example, autonomous robots, autonomous cars also that are communicating next to each other via networking. They also use GPS timing systems. So there is a lot of risk that you might have with a lot of the applications that are adopting GPS itself. So yes, should we be concerned? I think there are several systems in national critical infrastructures that are relying in GPS as a single point of failure. Definitely the GPS signals, as you know, they are quite vulnerable to some disruptions, and could be space weather effects. I mean, we have the beautiful, I think yesterday I saw some very nice pictures from Norway, etc., with this aurora borealis, beautiful things. But actually, those type of effects can also affect GPS systems, or interference, or spoofing. Also, GPS systems are relying more and more on software technology, so making them also a bit more susceptible also to cyber attacks itself. And yeah, again, even system anomalies could cause problems. As an example, if the GPS constellation could have a failure, call it maybe a rollover clock timing issue, then of course, then that could also cause some problems in the GPS systems as well, and then in the final applications. Anyway, very briefly, just to let you know who is Septentrio. I'm coming from Septentrio. It's a company that we do GNSS systems. And yes, as it was mentioned, indeed, we focus mainly on high-end GNSS positioning systems, bringing the accuracy side, but of course also the reliability and availability, and more important, the security. I think that's also where we are well known. We have different type of markets, applications, all the way from robotics all the way to timing applications as well. And the type of products basically that we have is it goes from system products, some timing products, as an example, that are used a lot in the scientific market, accelerators, as an example, in Switzerland, using these GPS receivers for very precise timing, or also modules where we have some core technology that also implements this reliable positioning, but also timing solution as well. But let me just tell you what's happening in the industry, in the general industry of GNSS. The GPS technology has become much more affordable. It's much more accessible to the user. So the expertise required in order to use a GNSS system is much better. I think there are quite a lot of power users or users basically that are starting to use that technology for the different applications. And this is what I call this democratization of the technology. And the same we get to see with other technologies, call it sensor fusion or connectivity systems, etc. But when you get to see, of course, is that the opportunities of the applications out there is also increasing quite a lot. There is a lot of new applications popping up because the GPS systems are cheaper, therefore they can be used with much more other systems as well. As an example, autonomous systems, as I mentioned to you. But the problem is that the risks are also increased because, as an example, the more that GPS is used, that means that there might be more people interested to attack the system or to hack it or to create a GPS disruption behind it as well. And unfortunately, the security side is still in the hands of some discipline and domain experts. So it really needs to get further away from there and to become much more knowledgeable for the standard users as well. So that's why it's really important to get to see in that. This is a pyramid that gives you an overview of the security in a GPS system in general. Let me start by the top part. I mean, a GPS system is connected to an antenna, which is basically tracking a GNSS constellation. I call it GPS, Galileo, Beidou, etc. And of course, in that system, you might have some level of malfunctions. Call it the satellite malfunctioning, because these are not perfect systems. Sometimes they will have malfunctions, which need to be well handled by the GPS system, but could also be other type of interference. Call it unintentional or intentional interference that you may have in the systems itself. And this is actually when we are talking about jamming, spoofing, beaconing, some of the aspects that are really interesting to understand how they are really tackled in the GPS system. Of course, there is a lot of other type of security problems that you can have in the GPS system. Many of you are experts in technology and security, so I'm sure you understand. Of course, yeah, there is a firmware that you have in this GPS system. You could hack it. You could access the boot of the receiver itself. You could modify the settings of the receiver. You could access the data and modify the data. So there's a lot of security elements that are also important to integrate in GPS receivers itself. But in general, I would say, I think there is a lot of technologies and techniques for the cybersecurity that can be used, and this is already well spread in the knowledge of the market of software security side. But for the GPS system is something that is really starting, and that's why it's really important to pay attention to those elements such as jamming and spoofing side. So again, very interesting to focus on those, and that will be the topics, big topics of the rest of the presentation as well. So let's first start by defining them, and again, I'm sure that some of you already are familiar with the terms, but just let's recap them just to make sure that we are on the same page. Jamming is basically an event that happens when there is a transmitter that is sending signals that are very close to the frequencies of the GPS system or the GNSS system. Could be very close to the Galileo frequencies or the beta frequencies, etc. So when this occurs, basically your GPS system will normally be unable to determine its position or the timing information due to this interference behind it. And here you can see a bit the diagram of that animation. Once you have that interference itself, basically the signal gets destroyed in that aspect. Or partially destroyed could be as well. As an example, one of the typical examples I give when on jamming is when you have your mobile phone next to a radio, you hear a bit of distortion. So yeah, definitely that's what you will get to see in jamming and interference. And unfortunately, to create a jamming, you will find this type of devices. These devices start from around $20 US. You can buy them on eBay. It's a USB stick, actually. You can plug it in your car, and then there you go. You have a jammer. And unfortunately, people don't realize the effect that these jammers can have, because these jammers, even if they are so small, they can actually be jamming for a vicinity area and therefore cause also some disruptions around them. And yeah, it's these jammers, again, people use them sometimes because they don't want to be tracked by their GPS, or a lot of the transport industry is using them also to avoid paying quotes in the roads as well. So yes, they are becoming really, really popular, and unfortunately, I mean, they are prohibited to buy, but you can still buy them quite easily and find them quite easily as well. So that's what you have with jamming. Spoofing, in the other hand, is when somebody uses a radio transmitter that will send a counterfeit GPS signal to the antenna, to the GPS antenna, in order to pretend to be a legitimate GPS satellite signal. And it became very popular with the Pokemon Go itself. Many people wanted to win points in the Pokemon Go and to be in a different location. So basically, they started to use these simple spoofing techniques in order to win points behind it. But yeah, now spoofing is also becoming more of a relevant problem. I would say jamming, we get to see a lot of events of jamming because jamming can be intentional, but sometimes can be unintentional. Spoofing is normally intentional, but yes, we get to see more customers and people basically complaining of spoofing in some facilities areas, and that's when they come to us, because yeah, we have a bit of the expertise in that side. How you create spoofing? Well, it's also very simple. You get this type of devices, as you can see here below, a Hacker RF, which is a system that is basically sending the signals, and then you just download some open source software, and that's about it. And as you can see here again on the animation, you can see the signals are not destroyed. The signals, basically the authentic signals, are overtaken by some other signal, therefore taking the device to another location, or the timing system to a different time, which is also quite possible as well to do. So I will go now a bit more in detail about the two aspects, interference and jamming. Let me start by jamming itself, because first question is indeed, how come do we see jamming in GNSS? Why is it so common, or why is it becoming so common there? This is the GNSS spectrum in terms of frequencies. What you have is normally higher band GNSS frequencies and then lower band GNSS frequencies. So normally L1 frequency GPS receivers normally are operating at the higher band, And as you can see here, it's also the band quite used by the aerospace industry, which means that they have to protect it quite a lot, as you can imagine, in terms of interference. So they really this frequency is rather well protected, as you can see, very well separated for different type of use cases in the band itself. So that's what happens in the higher band. But when you take a look at the lower band as well, you will get to see that there is a lot of other frequencies as well available there, and that can also cause some problems. So let's go in more detail about the lower band and all the possible systems that are out there that could make you some interference. So again, these are the lower frequencies in megahertz. And you can see, as an example, aeronautical systems. They are operating in the same bands as the L5 frequency of GPS or Galileo. Then you have another case, radio localization systems, which are also operating very similar in the L2 frequency of GPS systems. And then you have another example here, and radio location systems as well, but also air surveillance radars. You have seen maybe this type of radars sometimes close to airports. And then you might also see actually quite often, amateur radio people or amateur TV radio people that are basically trying to make transmissions, and they use this type of frequencies in order to transmit their radio or their TV program, whatever is behind it. So as you can see, this shared spectrum means that there might be quite a lot of interference in the GPS systems side, and therefore it's becoming more of a problem. Here is an example. This is our basically our amateur radio guy. He has all his beautiful equipment in order to do some transmission of radio. He believes that he's not actually affecting anything, but in fact, actually, you can see in this case, actually, this is a monitoring from one of our receivers, and you can see that we detect basically that type of spoofing, which is basically the video signal that he's using here, and it's very close to the GLONASS constellation L2 frequency itself. So definitely, again, an important risk that you may have there. What happens in a GPS system once you have interference? Well, if we are talking about timing receivers, that means that you will have problems with the precise timing information. Either the information will be wrong or the information will be absent from the GPS receiver. This really depends on how the GPS receiver is reacting to that interference itself. And you will see normally, very typically, when you take a look at the tracking of the signals, basically the carrier to noise gets lower in the system itself. So this is the best way to detect that there has been some interference in the system itself. You can see here as an example, the L2 frequency is quite low in terms of dB tracking information. This is 30 C/N dB, so definitely quite low here. So again, this wrong timing or absence of timing is the first type of symptom that you may have, but this could also lead to other problems as well in the system behind. Actually, this is an example. This is actually a test that we are doing with one of our GPS receivers with another module actually next to it. And then we click actually the jammer that we are putting here with the splitter itself. And well, normally what you can see already, the green lines here from the other GPS receiver, basically they go immediately low, while the other receiver itself keeps the tracking and keeps also the position and timing information. So there are different type of attacks. Nowadays, most GPS receivers, they have a level of anti-jamming and anti-spoofing. Unfortunately, they are not all to the same level of protection. It's really different layers of protection that you will have with this type of systems as well. Here, let me introduce you to Maker Vlog. He's a YouTuber guy, basically, that explains you how to make a jammer quite easily. And basically, he just tells you how to get the hardware equipment and how to neutralize some frequencies, including satellite information. And yeah, definitely, again, the technology for creating a jammer is quite well spread out there. So yeah, the program is becoming very, very popular as well. So again, as I was telling you, can all the different GNSS receivers have the same protection? Because again, yeah, many receivers will tell you, yes, I have anti-jamming, no problem. I have anti-spoofing, no problem. Well, it depends really on the techniques that they are applying in the GPS systems. And these are the basically the three blocks of techniques that are used in order to do some protection for anti-jamming. Number one is hardware itself. The hardware, as you can imagine, the hardware will have to put maybe some filtering techniques. We'll need to be very careful on how the GNSS tracking signals are done in the core front end of the GPS receiver. And there might be also some proprietary IP techniques mechanisms in order to protect for anti-jamming. So this is indeed the first one, and I would say the more important one. This could also mean different costs on the GPS receiver, because you might need to include other type of components when you are using basically this anti-jamming technique. This is also one of the reasons why some of the low-cost GPS systems might not have that protection, because the components that you might need are indeed more expensive behind that. Then you have software techniques. So yes, you could take a look at post-correlation techniques behind it, control of the gain, basically APC gain systems to monitor that. You could do some profiling of all those different type of jamming and detect them. You could use artificial intelligence, why not, and machine learning in order to predict basically, this really looks like a jam in itself, so I will basically not use that signal and rely on other signals as an example. So definitely there are some software techniques that you can do. And of course, yes, you could also use some external verification behind the GPS itself. This is what you get to see quite a lot, I would say, in the timing market. There is a lot of companies trying to bring indeed either protection with antennas or protection with maybe other type of sensors, or possibly other type of timing systems that are basically helping to detect this system of jamming itself. So what you have to think about is that the more protection you have with all these three techniques is the better, and especially at the core of the GNSS, I think that's the more important, because then the core chipset itself knows how the signals look like, can really detect if that's really a GNSS. The know-how of all that analog frequency analysis is much better handled, of course, at the core hardware and software side inside the GPS receiver than versus an external verification. But yeah, the sum of all these things will, of course, make things better as well. This is just to give a high-level example of the different type of jamming scenarios. In this case, actually, just a comparison versus Septentrio, but just take it as a generic type of message here, which is, okay, there are unintentional type of jamming, and there are some intentional type of jamming. Unintentional, as an example, you will have in-band interference. That's actually sometimes one of the more important jammings, which is actually people creating interference by themselves. When they are integrating a GPS in the electronics themselves, sometimes they have maybe a CPU, call it an NVIDIA CPU, call it a LiDAR, or call it other type of sensors, SD cards as an example, or the things that could be creating harmonics very close to the GPS system itself, and then giving you problems behind. So yeah, there are different techniques again that could be applied. In this case, just to give an example, with one of our receivers, actually we can be 10 times closer than other type of GPS receivers in that respect as well. And then you have very fast response to that type of system as well. Then you have other type of out-of-band interference. So that could come from cellular networks, SATCOMs, UHF, as example, 4G, 5G networks, even LTE 4G as well, will also create some interference by themselves. So yes, it's also important to detect that. There are even some talks, as an example, in the US about systems like Ligado and other type of systems that could be operating also very close to the GPS bands, but still out of the band. But yeah, definitely you need a bit of robustness behind that as well. Then a bit more in the intentional side, you will have the CW jammers, chip jammers. These are the ones that I told you that are very cheap to get. Or of course, you could go to very extreme cases where you will have military type of jammers. So as you can see, there are different type of jamming scenarios or jammers out there. And yes, if somebody tells you, yeah, I have a jamming protection, you really need to understand, okay, but what is really the type of jamming, anti-jamming that you have? Can you survive chip jammers? Or can you survive a bit more military jammers, etc.? So the technology will be definitely different behind these levels of jamming. And yeah, every GPS receiver might have advantages or disadvantages with respect to this. These are some of the techniques, as an example, that we use in some of in all our receivers. But yes, it's generic techniques. As an example, something that we have is what we call notch filters, and a notch filter basically will allow you to remove an interference. If you say, I just want to remove this level of frequency here, and then you could basically just filter out that manually. That's one way to do it. And then for every jamming frequency you have, you could basically apply that notch filter itself. But you could also have a bit, even for the wideband type of interferences, you could also have a more automatic mechanism and evaluating the spectrum frequently and cancel all those type of peaks of jamming itself. Therefore removing the jamming as example of chip jammers or some short pulses or some wideband interference behind it. So this is what we call again the wideband interference mitigation unit itself that could operate in GNSS systems. There is also again a bit more automatic mechanisms. Something here is an adaptive notch filter. Why? Because normally when you have again a filter, okay, maybe that filter will not be sufficient. Why? Because there is more of a frequency range that might be changing over time as well. So you could have these adaptive notch filters, which will allow you to be much closer again to the sources of jamming as well. It will be more automatic and seamless in order to automatically remove that jamming side itself. As an example here, you can see the radio amateur that we show. In this case, is automatically rejected by the system because of this adaptive notch filter itself. So this is one of the techniques. Something very important in GPS receivers is the flag, right? I mean, you as integrators of timing systems, you just want to know, hey, is there jamming or not? And that's basically something that has to be as truthful as possible. Otherwise, you will have a lot of false positives behind that, or the other way around. So very important to consider that information there. And yes, at least in the receivers, we actually give even more information, for instance, the spectrum, detailed information about the interference, and also, yeah, even a bit of the when it occurred, what is the center of the frequency of that interference, and what is the bandwidth of that interference. So you want all that information because that can also help you to take some decisions in the final system itself. There are other possible type of interferences and effects. I will not go in detail, but in general, maybe about the techniques as an example, if you have dynamic range issues, frequency diversity is a very good technique. What do I mean by frequency diversity? You have GPS systems that are single frequency. You will have GPS systems that are dual frequency, so that makes them a bit more robust, because then there will be backup signals where the GPS system can fall in case that one frequency is jammed. But if you have a triple frequency GPS receiver, it's even better, right? Because you have more diversity again on the frequencies to analyze and to detect interference behind it. The WIMO, we already discussed it, especially with time variant interferences as well. And also, as we discussed, the electrosmog or the interference that sometimes people cause by themselves, it could also be affected. Normally, yeah, you have the certification of your electronics, and there is a section for it, which is the 15 part B, which normally it says that you should be already on this 105, which should already hurt. So yes, even if you have those certification parts, you might still have some interference, because you will be very close to the GPS signals itself. So there is a lot of protections or other mechanisms you can use. More important is monitoring, because if you have a nice spectrum analyzer that can allow you to do the monitoring of the jamming, then you can do a very nice electronics integration, and that's one of the advantages as well, to have that information inside the GPS receiver, a monitor inside the GPS receiver that can help you. So could we demonstrate jamming on its effects? Well, I already showed you some examples at the beginning of this presentation, but this is just another case study here. What we did is we put two antennas, a GPS receiver in the top of a bridge in the highway. Why? Because we wanted to detect interference in the different lanes. So basically, we put two GPS antennas just to detect where the interference was coming in which lane. And it was very interesting to see that, yes, we detected that in the low speed lane there was quite a lot of interference, and this is caused a lot by these systems. In Europe, these trucks, basically, they need to pay fees which are monitored via GPS. So many people don't want to pay the fees, and they just put the jammer. So at least what we detected in 4.8 days, we detected 45 events with different type of jammers. You can see chip jammers, pulse jammers, and the other type of jamming inside. So jamming, you will see it more often again than is predicted. And as I told you, again, there is a lot of self-interference. Also, this is an example in a UAV. It's a different use case than timing, but yeah, sometimes a lot of the internal jamming could also be interesting to monitor there. I will go now to spoofing. Yeah, and by the way, let me know if there are any questions. Don't hesitate to interrupt me. Feel free to let me know. I cannot see really the chat box, but yeah, let me know if there is anything. I will now move to spoofing, just to explain the spoofing, what is it about, and what are the techniques also that are used in the core GPS system to protect against those things. As we were talking about, normally spoofing will be taking or pretending to be an authentic signal, and therefore taking you to a different position or to a different timing. So it's not only position. Remember, you could also spoof perfectly the timing quite easily and take a system to another time side as well. So some people think, okay, spoofing is not really an issue. We don't really see it often. But you will see that there are more and more attacks also behind it. So let's first try to understand basically the types of spoofing that can be happening. So normally a spoofing attack can be created taking into consideration the following: the intentions of the attacker, the equipment that they have at their disposal, and the knowledge of the spoofing techniques. As I told you, normally spoofing is much more of an intentional attack that you will find there. But yeah, it will really depend how much the attacker wants to block you and how much money he has as well. The primary types of attacks that you will have is, as an example, non-coherent attack, which is normally also called asynchronous attacks. You will have coherent attacks, also known as synchronous attacks. Cover attack as well. In that case, you are really blocking the signals and then putting another system on top of it. And mid-conning attack normally happens a lot with repeaters. As an example, factories that are fabricating systems which include the GPS, sometimes they have these transmitters or repeaters in order to have that in the production facilities, but sometimes these repeaters can be also quite powerful and also cause problems. And we have had also quite some cases around the mid-conning type of effects as well. Normally, when you have spoofing, which is really malicious, people will combine it with jamming. That's also something interesting to mention. But yes, people normally will combine these techniques as well. But here you can see already our spoofer. He has a powerful transmitter, and yeah, basically he's overtaking the authentic signals, and basically instead of the correct time, will take you to the wrong time behind it there. So this is something that could happen. So now let's try to understand these types of attack, the non-coherent attack. Let's start with that one. That one is a rather easy attack to make. Normally, what you do, and you can see it a bit in this animation, I hope is visible, but normally you have another powerful signal. You can see the green signal, which is the spoofing signal, and normally it increases the power in order to basically indicate to the GPS receiver, hey, take more attention to me versus that authentic signal. So this is normally the way how that non-coherent attack happens. Usually it's also quite well combined with jamming as well. In the other hand, it's also one of the easiest attacks to detect in the GPS system, because what you will notice is that increase of power, that sudden increase of power of the signal. So you can take a look at some characteristics of the signals itself, and then you will see that it's very easy to detect that attack. But then you have a bit more complex attacks, which is a coherent attack or synchronous attack, as I mentioned. This is more complex. And why? Because what happens is that spoofing signal, what it does at the beginning is first align to that authentic signal here in the blue, as you can see. Then it increases the power, and then it moves away out of it, having some similar characteristics as the authentic signal, but still a bit more powerful in order to drag away the system itself. This is what we normally call the walk drag away of the spoofing attack itself. So it aligns to the authentic signal, it increases the power, and then it takes over in a gradual move. So it's a bit more difficult to detect in that case as well. Then you have mid-conning, which is also even a bit more difficult to detect as well, by the way. What happens with mid-conning? Mid-conning is rebroadcasting signals that are actually authentic. So in that case, basically, you have the spoofer. The spoofer has kind of a GPS system as well. So he's tracking authentic signals at that moment, and then he transmits those signals with slight modifications to the GPS antenna, and therefore you will have a runtime at the end. And this is again, more difficult because you need a bit of knowledge of how to modify those signals. You need a bit more equipment behind it, but it's more powerful because the GPS receiver cannot detect that differences in terms of the characteristics of the signal. It looks really like authentic signal, so it basically will lock into that signal quite easily as well. So these are the types of attacks, and this is actually the history of spoofing attacks, just to show you that they are becoming more reality. This is what I call from fiction to reality. The first spoofing attack, I think you saw it in the James Bond movie, which is Tomorrow Never Dies, and you will see in an episode, basically there is a spoofing attack where there is something around the Chinese borders basically happening, and then you have an attack behind, which was unintended, of course, but yeah, there was a fiction behind it, but then it became much more reality. And you will see later on there were quite a lot of studies in universities, again, just like it happened with viruses. As an example, in the University of Texas by Dr. Todd, who's an expert actually in spoofing. Really, he knows everything about jamming and spoofing. well, he started to demonstrate the first spoofing on a helicopter drone as well, and an 80 million superjet that was also spoofed. So yeah, definitely very interesting to see that and how it has progressed more and more in terms of spoofing attacks. This is continuation of the timeline. You get to see that it keeps growing and growing, the attacks, and even nowadays, of course, unfortunately, due to some of the geopolitical situation, the attacks are also more common in certain areas also of the world as well. So yeah, the problem is increasing quite a lot, especially in the last 3 years as well.
Okay,
So,
hang on. I would like to.
sure.
You welcomed the interdictions. Okay, I have an interdiction. Can we go back to the previous slide? Do you have any proof that any of these attacks actually happened because of spoofing? Okay, I remember, for instance, the British oil tanker and the crew seized by the Iranians.
Yeah.
It was not in Iranian waters. The Iranians claimed that, but it was not, in fact. I see all of these as possible to have a proof of a single case where it was definitely spoofed.
Yeah. I think
For
what
instance, you also
the one.
do in the previous slide. You do also one where you have a U.S. drone, blah blah blah, and it starts out fictional, right? You have also one with a U.S. drone and so on. But in order to spoof a flying drone, you need to literally impact the receiver from above, right? So you need to fly along with it at a high altitude.
No, not really. Actually, spoofing can perfectly come from the bottom. That really depends on the antenna. The antennas, for timing antennas, there is a lot of timing antennas that have been created particularly for timing in order to not have signal tracking from the bottom, but those are very dedicated anti-spoofing type or anti-jamming
So the type of antennas we
antennas.
find on U.S.
But
military drones flying close to Iran, I guess they would probably have those
yeah.
type of antennas. But anyhow, is there any case where we definitely know beyond a shadow of a doubt that it
Yeah.
was because of spoofing?
Some of these events, yes, and some of them are very visible. The circles, as an example, that you get to see in China, and also it happened also in Tehran, in Russia as well. You have some very concrete examples of spoofing that are really proven. You have the data, and actually, some people are even quite open about it. By the way, Russian have been very open about the spoofing attacks that they do and the techniques that they also use. Some, like the British oil tanker that you mentioned, that's a very good question. In that case, there was a question mark behind it. Of course, you will have a bit of discussion around it. Again, lots of these ones sometimes are analyzed by universities and by experts behind it. Many of them, they think it is indeed the spoofing attacks there. But yeah, some of them are very visible. As an example, I don't know if you have seen the circles of spoofing that happen in China. I mean, that's really, you will see it actually in one of my next slides. It's very clearly a spoofing attack. There is no other thing than a spoofing attack behind it. I don't have it here. You will see it in one of the coming slides.
One question, Gustavo. Like, let's say
Sure.
in case of these circles that I see, like these patterns and so on,
Mm-hmm.
are we moving toward like better, let's say, INS systems that they do, let's say, fusion with some like IMU, so you don't need to, like, I'm assuming what is happening is like basically they have a stationary point that is just going around with a spoof. So then when you have a vehicle coming there and he's like, let's say, relying on GPS to do like the basically next point, it will go through this looping, and then like you basically get trapped in that.
Yeah.
I mean, most of these things, they can definitely, I don't know, I mean, in terms of the navigation
Detection.
systems, yeah, they can definitely benefit from a lot of fusion, you know. And let's say
Yeah.
for the timing one, I thought, I mean, this was like for thoughts, you know, that's why we have, let's say, an atomic clock on the time card, for example, that you rely on. I mean, even like the SA-53 has an engine to take care of this. Like, wouldn't that be the case? Like, so I would say for the attacker, spoofing is much harder than just scramble everything in case of jammer. Is that true?
Honestly, so you are right. There are external mechanisms, and I will come to that in order to detect spoofing. You are totally right. INS systems, as an example, is a perfect example on how to do that. What could be the risk is actually how the attack is done. So a gradual spoofing attack is going to be very difficult to detect.
Ah.
As an example, if you
Can
have
I
an
chime in
idea,
here? Can I chime in
sure.
here? I'll add one other dimension to this, which is, you can do a search on the internet and find real spoofing events. The U.S. government
Approved.
has quite a bit of,
Confirmed.
of information about that, which
Yes.
are real. And so, one of the things I just want to add to this conversation is sometimes these, spoofing events are always intentional, but there's one thing to detect spoofing, and there's one thing to protect from spoofing.
Yes.
So
Yeah.
when you said, Ahmad, using an oscillator, that's one very good way of maintaining your time so that you can kind of predict, how time moves forward when there's a spoofing event. But of course, that oscillators have degradation, so over time, your accuracy will degrade over time. So there's multiple different ways to prevent spoofing, and I know Gustavo very well, and we discussed this a lot with the people at Septentrio. And there's two different camps. One is spoofing detection, and then what you do once you detect it, and one is spoofing. The other one is spoofing protection, and there's several different strategies for doing that.
Yeah,
Can I
one more
ask
thing,
if
Jaime, like I was quickly. So
yeah,
another thing I was thinking is because you are feeding a system the inputs and how the control loop, all the filters and everything, are handling things. You need to have like tremendous information about that system and its vulnerability. Let's say, for example, in any of these cases, I will, like, if it's in my control and I'm like overseeing the design of whatever device that is consuming these things, I definitely will have some filtering there to avoid like noise and everything. And now when you introduce something new, it is definitely much harder. As I said, like I was just saying, I'm not saying this is like impossible. I'm just saying it's much harder, let's say, in compared to, let's say, jamming. You scramble the whole area. That's all I was trying to basically emphasize on.
Yes,
and
yes, of course. And I'll give you one example. One thing you can do is comparison. So
Yes.
if you know the quality of your oscillator, right, the receiver can compare the timing that's coming from GNSS
Yes.
and if to the oscillator, and if there's more than an X amount of variance between what the oscillator is reporting as your, let's call it 1 PPS versus the 1 PPS it's getting from the signal in the sky, if there's a
Yes.
big difference between those two, it can say, well, there's,
Yes.
something going on here, right?
Absolutely.
That's
but
one example.
but
But you're
can I
right,
just
it's much more difficult.
but can I just
I think it's very similar to what I have here, but this was a backup. I was
Oh,
not intending to show you, but it's indeed the control loop that you are talking about, and this is
let's see what
maybe
Lasse wants
oriented
to
to.
ask. Lasse, go
but
ahead.
hang on a second. You see, what gets my back up, okay, whenever somebody discusses this issue is this, okay? Uh, I accept that you can jam a GNSS receiver, okay? If it's a cheap one, you show some police camera on the road, this is fairly easy, and you can buy it on eBay, okay? And yes, you can do spoofing. This is quite complicated and it requires expensive equipment and it requires advanced access to the antenna and knowledge about the system. But
Yes.
here's my problem. Okay? Earlier, you show a slide where you have a plane on approach and you show the flight path altered and you write on top of that slide GPS spoofing. Now, I happen to be an expert in clock synchronization and timing, but I am also a licensed pilot with an instrument rating, okay? And what you present there is quite frankly fictional and alarmist, okay? A plane which is on approach full of
Totally
passengers
agree.
have an ILS system, okay, which relies on microwave at the beginning of the runway for both its horizontal and vertical location. It has distance measuring equipment, DME. It has VOR. And if it is a passenger plane, it also has a radar altimeter, okay? And it is fictional what you say, right? It just isn't true. That
Well,
even if
let
somebody
me.
had the
You're
capability
right.
to do GPS spoofing, they could alter the flight path of an aircraft on approach. You know,
Sure.
that isn't true. That's alarmism, right? It's like when that guy from the GPS Resilience Alliance, Gina, whatever his name is, when he shows a laser on the ground shooting a GPS satellite in space. Okay, that's Star Wars. It doesn't exist in the real world. Anyhow, I just wanted to. Many of the things
To
that you
illustrate that.
say are reasonable, but some of
Yeah.
it is deeply
Let
exaggerated and science
Yeah.
fiction.
Let me comment on that. So you're right about the plane. I totally agree. Normally, spoofers will not really go to a plane. That was more of an illustration. Drones, however, I can tell you, we have worked with a company which is called Spirent. Actually, they have done some testing together with the military in drones, trying to prove that you can spoof a drone. It's very, very possible. Basically, they managed to spoof the drone without problems in that case. So, sorry for the plain picture, you are right, but spoofing is a real problem that you may have. How often it can happen, that I agree with you. The attacks of jamming are much more than the attacks of spoofing. But yes, the technology you were mentioning that the technology is much easier to have in jamming than spoofing. Well, the technology in spoofing is also quite simple nowadays. Before it was quite more complex. Nowadays you can have some spoofers as well.
Yeah. Okay. I just wanted to I just it's always tempting like to overstate some things, and you know, if you work for a company that sells resilience to GNSS and so on, okay, I can understand the temptation, but we also have to be careful a little bit with let's say. I mean, I'm not saying some of these things couldn't happen. I'm just saying the chances of one of those things getting hit by an asteroid coming in from space and being destroyed for that reason is 3 orders of magnitude higher than some of the scenarios presented. Okay, anyhow, that was
but also in fairness to basically Gustavo's argument, a lot of these things when they go through, let's say, risk analysis, and you have like, I don't know, some crazy numbers of nines, and like, I don't know, there's a lot of money involved. You want to really reduce the chances. And I agree with you. Let's say, for example, because the same argument definitely has been there going on, let's say, for that aircraft, or like, I don't know, again, more expensive thing where people's lives are like, you know, in line. So then you go for, I don't know, all kinds of like optical IMUs or whatever, all of these things you put on board and you take care of all of these things. But let's say, for example, in the case of, as Gustavo was saying, like in case of military, like, I don't know, Switchblade, things like that. Like these are supposed to be cheap, you know, like you don't want to add too much sensors. So then that's, I think, where the vulnerability comes in. And I see this niche there. I see both sides. I agree with what you're saying, the probability, and I also agree with what you're saying, Gustavo.
Yeah, I think there is you just said it actually. There is and this is actually risk analysis, as you mentioned it. There are two parts of risk analysis always. Normally, number one is the probability of
Yes.
something happening, and then the other one is the impact of something happening.
Yeah. Probability, and then
It might be that happens
by that.
in one case, but if it happens, it could create a big disruption
Yeah.
behind these things. And I think that's where normally, yeah, you're right. Governments and different people take attention to these type
Yeah.
of things.
Yeah, I can give
And
a
it's
quick
happening.
example. I'll give a quick example to that point, which I agree with. For example, in my past role, I was working with large telecom operators that would put our timing technology into radio base stations. Okay, and for a couple years, we had mentioned to them, "Oh, you have to be concerned about potential jamming and spoofing," and their answer was always, "We have millions of your receivers out there, and we don't see any jamming or spoofing events happen.
Yeah.
Well, what happened over time is that the jamming and the spoofing events started to happen. And when these started to affect radio base stations and there was no internet and there was no voice communications, then they panicked and they said they needed a solution for that, right?
Yeah.
But we had been bringing that up for the previous 2 years, and their answer was always, well, there's nothing happening, there's nothing happening. And so I think that the ultimate message here is you have to be proactive about protecting against these
Yeah.
things and not reactive
Exactly.
against protecting these things, because we can all argue about how much
Yeah.
it happens today. Okay. But is it going to continue to happen? Yes. And is the frequency of this happening increasing? Yes. So,
Yeah.
you have to take a look at that way and then consider how you want to implement a strategy. Right?
And then the strategy is also indeed the application, right? I mean, maybe for some applications you don't care. I will not sell you my GPS receiver. Some applications where the spoofing impact is low, right? That's not where you want to put this type of technology. You want to be really choosing what are basically the use cases where this type of technology could fit well. And that's again, you have different type of jamming and anti-spoofing type of hardware out there, all with the different levels of protection. You need to assess that for the different use cases.
Yeah, precisely.
So yeah, this is actually how to make spoofer, and this is 200 US dollars. You could even make it a bit cheaper with $5 US,
You
by
could
the way.
even get
But
for HackRF, there is also something called Porta Pack. You put on top of it, and you don't even need a computer.
then you didn't even a computer. Well, in this case, actually, you
Portable,
can use
portable.
even this. Yeah. So
We
again,
use it.
everything is
We use
open
it as a
source as well.
GPS simulator, like in the lab. So it's literally a spoofer,
That's a good idea. That's a good idea as well. So yeah, the hardware to make these things is simpler. I don't have to prove you again an spoofing attack. I'm sure you have seen it. This is a spoofing an iPhone, so those are quite easy to spoof around, and it takes us to the Everest where we were not really located.
Look for a
But at
Pokemon.
least we got a Pokemon there indeed. These are the circle ghost ships actually. So this is really real data again. This is, I mean, there is no other explanation than GPS spoofing in this case. So yeah, now there was also an accident around the area that you cannot really prove that it was caused by the spoofing. That's very difficult to really confirm it. But yes, it happened around the same time. But what was really clear is that there was, of course, a spoofing in the area. As you can see very clearly, those are circles here in the region itself. So it happens. Sure, this is again people that can make this type of hacker spoofers there. Again, a YouTuber explains you also how to make GPS spoofing again with this type of SDR. So the technology is becoming rather available for people. And I think, again, it's mainly the awareness. You decide yourself what is the use case and where do you apply it. But yes, the awareness basically behind these things is interesting. So then we come to the protection and how to detect it. As you were indeed mentioning, there are these two parts, the detection and the protection elements behind. So these are the techniques. You have cryptography as a number one technique, which basically is using the standard techniques that we know in authentication in order to say, I am a real authentic signal coming from that satellite, and this is your public or your private key, and then definitely you can authenticate those messages behind it. And there are some constellations that are already doing that. As an example, Galileo OSNMA is already doing that. They are already sending some signals behind that. GPS is a bit delayed on that, but they will come, of course, with also something similar, which is GPS Chimera or Camera. I'm not sure how to pronounce it. And then, of course, yeah, you have other code encryption mechanisms or systems that could allow you to have that cryptography. PRS or P code is normally what's used by the military systems, indeed, in order to do that protection. Actually, they use much more these techniques in there. Then you have another mechanism to detect spoofing, as we mentioned, taking a look at the signal features. is, as an example, the angle of arrival, the AGC gain, the noise floor, the clock jumps. As you know, you mentioned it yourself, there are a few things you could take a look at there, but this is at the GPS receiver level. How can you take a look at that? And then there is external verification. You mentioned it yourself. You could use IMUs, you could use other type of oscillators, etc., to detect this type of problems again. Yes, yeah, you will detect some spoofing attacks as well as we discussed here. But the more, just like in jamming, the more mechanisms that you have for anti-spoofing, the better. It's the same as in security. I really see it the same as security. The more doors that you have open, the possible risks that you will have in security. So yes, the more techniques that you can apply in a total system, the better will be for the whole security in spoofing side. This tries to emulate a bit what we were discussing in terms of, hey, how cheap or how expensive is to have a spoofer. And yeah, again, we said you can create spoofers in a very cheap way with free software behind it, or you could go to a very expensive simulator, which truly indeed will reduce the risk of happening. But if it happens, it is going to be a real attack in that case. And I can tell you that many GPS receivers will not be capable of overcoming that type of spoofing attack itself. So you have all these type of spoofing systems. I see it like the Mona Lisa side. So if you have a very cheap free software SDR, then okay, then it's going to be very easy to detect the spoofing attack. You say, okay, this is not really the Mona Lisa signal that I'm expecting. It's a spoofing attack. If you have a portable simulator, which is a bit more expensive, then the Mona Lisa will look a bit better, but still not yet there. But then you could have a highly advanced simulator, which really makes much closer view of that Mona Lisa, maybe with the special features behind that you could still detect if you apply the right techniques behind it. But yeah, as you were saying, there are two parts. One is indeed the mitigation. The other part is that detection itself. So it could be that in some cases, let's suppose that the Mona Lisa was backwards, but it's the authentic Mona Lisa. So you could have some false detection in this spoofing flags. And this is what you get to see, unfortunately, with a lot of GPS systems. They have a flag of spoofing, but it's not really reliable behind it because yeah, it has a lot of false positives or something similar in that case. So yes, monitoring reliability is also quite important behind. This is just an example again to show the response on a chip system here. As we were mentioning, it's rather easy to detect the spoofing attack. In this case, you can see it here. This is the web using the interface. Yeah, we detect in this case the spoofing, so it's quite simple to detect that. If you go to a more advanced scenario using a simulator, yeah, in that case, we can still detect a few things. Again, taking a look at those characteristics a bit more in detail of the signal itself, and then we could also detect those type of things. But let's suppose that the simulator solves for those anomalies. Then at that moment, then the best is to use the authenticity, which is basically the cryptography mechanisms that we were talking about. So the Leonardo da Vinci signature, you want it in the signal, and therefore that's provided by GNSS constellations. Galileo, as we were mentioning, provides that type of authentication using navigation data that sends basically those encryption keys, and then you can do a final authentication for the signals themselves. So in general, indeed, is already a very good system for authentication, which is, again, this open service navigation system is for free, by the way. The signal is for free. Of course, you need to have a system, a GPS system that can decode those signals, and that can also yeah, basically make use of the signal information. So that means a bit of software that is also doing the decryption behind it as well. As you can imagine, decryption keys, it could also be CPU intensive. So you have to also be careful that the GPS system has enough CPU power for making sure that you can implement this authentication mechanisms. They are like in security, of course, GPS intensive. You have to imagine that for every epoch of signal, you need to authenticate it properly behind. So the system is already, by the way, in an initial service, so it can be tested as well. So that's nice to see. And you can see it here a bit operating as an example here on an authentic signal. You get to see OSNMA authentication is already there. So you can see here as an example the satellites that are authenticated. Unfortunately, Galileo is only authenticating Galileo signals. That's kind of a disadvantage there, but yeah, they only do that today for Galileo systems. Here you have the example of incorrect authentication. So you will have the fake signal again here detected as well. So yeah, it really helps to have that authentication, that cryptography mechanism as we were discussing for anti-spoofing side. So again, it was only for Galileo, this Galileo OSNMA. So what about GPS and other systems? As I mentioned, GPS is also going to bring the same type of mechanisms also for authenticating signals. The timing is still to be seen. They had a few trials already in 22, but could still take some time before the system is operational in that case. What I can tell you is that basically the encryption here is more complex. Basically, the handshaking of this encryption is more complex. So you need to take into account indeed again more CPU even than what you have in Galileo side. So it's something to take into account in the GPS systems as well. And yeah, very high level. Just to let you know, it could be that you have this authentication coming from GPS systems or from Galileo, which are the standard constellations, but it could be that there are also other services out there that could help you also to do authentication. As an example, this is the case for the Fugro Atomicron service, which does not provide only authentication for GPS or Galileo, it provides it for all the constellations. So it has a nice advantage that could be also used in GPS systems as well. So just like Atomicron, there could be other services that could be implemented in order to give you some extra, at the end, timing information of the satellites in order to detect that those type of spoofing attacks as well. So very brief wording around Atomicron. It's a dedicated timing service for providing precise timing information. So it's not going to be only anti-spoofing side. It will also provide high accuracy in the timing because it's kind of using what is called normally corrections systems of the GNSS system. So you could have very high precision, as you can see, lower than 5 nanoseconds, lower than 1 nanosecond with the Figaro time scale itself. So yeah, the timing precision could be also very interesting for some use cases. You know more than me indeed the type of use cases, but yeah, it will provide us two advantages, which definitely is also interesting as an alternative system. Yeah, we talk about indicators, about the flags. That monitoring is really, really important because at the end you are taking decisions on your final system to either use alternative mechanisms for timing or to stop your system and give alarms to the end user. So yes, all those flags are really important, and the reliability of those flags, it also has to be fine-tuned, and this is also something that requires a lot of data. As you can imagine, this is a bit of what we call the heuristics, taking a look at lots of data out there and trying to see if to create models basically to detect spoofing in a better way, and then to say, okay, this is really a spoofing attack or a jamming attack behind it there. So yes, my general recommendations on the timing is, yes, those flags are the best, not only to use the spoofing and the jamming side flags, but also to use the authentication flags, because that can also help you to say, hey, this system is not only protected, but it's also, I see no jamming or spoofing flags behind it. So this is how your control loops also could definitely use information in the best way for detecting the timing, and then you will have a nice Mona Lisa at the end behind these things. very briefly, I don't want to be very commercial, honestly, but just to let you know, there is the module that we have for timing is the mosaic-t is a timing module, which is a multi-band, it's a triple frequency band. That means that you can benefit of those multiple bands in order to detect the jamming side, as well as also for spoofing, can also help you in that case. It's a module that can be that can be soldered, and it has also dedicated inputs for time and the frequency synchronization aspect as well. And it uses again all those mechanisms that we have discussed for the anti-jamming inside the core GNSS itself. So we don't have IMUs or external mechanisms implemented, but yes, all the other core mechanisms inside the GNSS is what we try to apply, and we call it basically just AIM plus technology behind it. For the rest is a bit of the advantages of the mosaic-t, which goes a bit further than only that resilience. You have dedicated timing features and other advantages in the module itself, in the core GNSS technology. Again, that could apply for certain use cases, certain applications. Not all the timing applications, I can assure you. Some of them maybe is better to use just off-the-shelf systems, but yes, for some use cases where you want more reliability, it could definitely be an interesting alternative. Features, I will not go in detail, but you have them here. I leave it to you in the presentation and the slides. You can always take a look at it or ask for further information. And very interesting to see as well that it's not me that did this study. There is a company that did an analysis of different GPS systems in timing to just assess them in terms of the timing resilience that they had for both jamming and spoofing. The company is actually called GPS Patron. So they did actually a very deep analysis and study with different type of scenarios. It's very nice because they also explain you how can you replicate this type of scenarios and test basically the system itself. So there was definitely good test behind it and some good report about it as well. So you can always take a look at that. But in general, my message is I really see anti-jamming and anti-spoofing as a continuous basically improvements. Just like antiviruses, you need the latest version of the antivirus, the same you need in the firmware systems. You need a GPS system that is updated with new types of attacks, with new type of techniques in order to mitigate that. And this is really, really important as well, to make sure that if you deploy a system with GPS, also make sure that you have a proper upgrading mechanism behind it in order to rely against the different type of disturbances. One of the disturbances I mentioned to you at the beginning of the presentation actually was caused by a lack of firmware upgrade. So yes, very important to keep that into account. I just put it here, by the way. I did not get a final approval, but yes, we are working also. Okay, thank you for that. I just very briefly, we are working with the team of Meta in making indeed a time card. They are making a very nice integration, so definitely it will be interesting to see also that coming up. And this is my final slide. Again, I see interference and spoofing as a major concern. I agree with the statements. Indeed, we don't have to exaggerate the occurrences of some of those, but I think it's still important to consider the impact of some of these things, because it's growing. It's growing, and it will keep growing. Why? Because GPS systems are being used everywhere. So take that into account. There are different type of techniques that can be available in receivers in order to mitigate this jamming, for instance, for interference. Filters or frequency diversity or adaptive filtering can help you to do this type of protections. For spoofing, normally I will say is the encryption signal cryptography mechanism. Number two will be indeed again diversity of the frequencies. Number three, I will say, is heuristics. You can use a lot of heuristics, and by the way, a lot of studies in artificial intelligence and machine learning are taking a look at these two, interference and jamming, in order to bring better techniques also there. And yes, there are other type of techniques, as I mentioned, out there. Call it antennas, call it other software layers that you can put on top of the GNSS receiver. For me, the more security that you add on into the system, the better. So it's not that one is better than the other one, but yes, it definitely can help you to add on all these type of security layers. No, it's like the typical onion in the security analysis that companies have. The more layers of security in the onion, the better, basically, for your system as well. So I think that's my general conclusions. There are some nice here links, by the way, you can find also for other information about jamming. They are not really commercial. They try to also go to a bit more detail about this jamming and spoofing side as well. So feel free to go to those resources as well. So that's what I have.
Thank you very much for this informative presentation. So let's open the floor for some final questions. David, go ahead, Hisham. Go ahead.
Yeah, one quick question. Can we use Chat GPT to test mosaic-t?
Sorry, can you use the
Chat GPT?
So how like, can you elaborate more on that? I'm curious.
Like Chat GPT can provide information about many things.
Yeah. The chat, You, I think I used it this week, and I was asking a bit of information around Mosaic, and yes, and Septentrio, and yes, it told me very generically about it, but maybe it doesn't go to that deep level detail. No.
Okay.
It's a very interesting question.
Yeah.
It's a modern question.
It's a modern
exactly.
question.
Yeah,
I was
exactly.
just testing it last week, and the first thing that when I asked about Septentrio, it told me, yeah, it's one of the companies focused on the resilience side. You can ask it. So it was interesting response I got in it. Yeah. Other questions?
David, you had a question about, is David still there? Yeah, David was, okay. So David, yeah, okay, sure. So I think it's answered.
Yeah, can you hear me okay? Or?
Yes, I can hear you.
Okay, yeah, so when I posted that comment, I was referring to the other speaker saying it was totally unrealistic. And I would assume there are some scenarios where we have even armed drones, but that definitely is realistic. Sometimes people, terrorists, are jury rigging these things with a $400 drone. So I mean, it is a concern.
Yeah.
And the one question I did have is, are there concerns about where it's not spoofing, but it actually is the operators of the satellites, I guess, doing the equivalent of spoofing? So, for example, how would some of these protection mechanisms work if they intentionally jammed Galileo and GPS, and then Russia and China teamed up to send bad signals?
Basically, big players causing spoofing.
Can you repeat the question?
There's not technically spoofing. It's the operator of the satellite network actually doing it.
Pulling the rug.
Can you repeat the question, maybe just to make sure I get it?
Sure. So normally when we talk about spoofing, we're talking about people trying to emulate the satellites, but not the satellites themselves. If two of the four major operators of these networks are our adversaries, how does some of those protection mechanisms work? If they, for example, with their satellites just over the U.S., jammed ours and Galileo, but then the Russians and the Chinese are favoring the satellites.
Yeah,
I mean,
it's very interesting. Yeah,
it's
definitely.
no longer unrealistic.
Yeah. No, I totally agree with you. And there was actually a nice article maybe a few months ago around it, actually. And it was indeed more into the attack of the satellites, of the navigation system, rather than indeed into the signal itself. Of course, those type of attacks go more into cybersecurity type of attacks in that case. But yeah, it was very interesting to see the article behind it. So yes, I think indeed it's a possible risk that this also could be realistic at some point. So there was a nice article behind it. I can try to find it and send it to you.
And then the other question I was curious about, so I know in the mobile phone space, there are cases where you basically have over-the-air exploits where you can take advantage of bugs in the RF portion. Have you heard of anyone being able to successfully do that on GPS receivers, where you're literally using the GPS protocol itself or other GNSS protocols to do code injection? So not just to spoof, but to compromise the receiver.
Do you mean to the output of the receiver itself, to cyber security behind the output of the receiver? Is that what you mean?
Yeah, so this is a common technique allegedly that's used to compromise, for example, cell phones. You basically inject
Yeah.
signals in the RF space, and they tend to have direct memory access, so they don't harden them as much as through the regular.
Yeah. So honestly, I have not seen those yet. I can tell you that.
That's a relief.
There is, I have not seen it yet. There is a nice website actually where you can take a look at vulnerabilities also from different products out there. So sometimes we have seen as example security risk on GNSS receivers, but which are unintentionally detected. As example, sometimes they are used by spamming. They use the IP addresses of the GPS receivers, because these GPS receivers are also becoming more network oriented as well, so they can access the system quite easily as well. But in terms of real attacks there, I have not seen it yet. And in the other hand, GPS systems are also incorporating better techniques as well there. I mean, you will see there are even some companies in the GPS area that are actually acquiring some security companies in order to stress more the security behind that. It all happened, as you can imagine, what I call the Huawei effect, which is basically the security risk in different telecom systems. That's where many companies started to pay more attention in security.
Gotcha. Thank you.
Mhm.
Okay, great. Any other question? Okay, great. Again, thank you very much for the presentation, Gustavo. So next presentation on March 15th will be by Dana Weinstein. That will be like really more into physics, which is about, again, sneak peek. It's basically an oscillator based on an effect in FinFETs. Basically, like there is a modulation effect in FinFETs that I think it's based on piezo, I'm assuming. And so that's vibration is basically an unwanted thing. But again, Dana's research is basically about how utilize that one and basically have a better oscillator than, let's say, an RC oscillator if you want to put it on a built in a processor, but definitely, again, not as good as, let's say, a crystal. So pretty excited to see that presentation in 2 weeks. Okay, hearing none, I will see you guys in 2 weeks. Bye, everyone.
Thank you, everybody. Yeah.
Thanks.
See you. Bye-bye.